utilization, maximize throughput, minimize turnaround time. So see that we have to minimize the turnaround time, means that when the CPU, when the process will come to the ready queue for execution, and it is getting the CPU, it is executing its task, and then it is leaving the ready queue. That will be the turnaround time, means whole time from coming to leaving. Okay, these times should be minimized here. Also, waiting time should be minimized here, and the response time should be minimized here. So, three different things. One is the turnaround time, the other one is the waiting time, the other one is the response time. These things should be minimized, and CPU utilization and throughput should be maximized. Okay. Now, we can have the algorithms like the CPU scheduling algorithms. This is called the single processor CPU scheduling algorithm. We have 4 algorithms. Out of them, 2 is non-preemptive and 2 is preemptive. So the first one, that is non-preemptive, is first come first serve, and the second one is the shortest job first. Then the preemptive version is here. One is the round robin and the other one is the shortest remaining time first. Okay, these things. Now, in the first come first serve algorithm, one example you can see here, some other examples you can see later also. The first example you can see that this is process P1 is here, whose burst time is 24. Okay. P2 is here, whose burst time is 3, and P3 is here, whose burst time is also 3. So that means the CPU time for a particular process P1 is 24, P2 is 3, and P3 is also 3. And the arrival time is not given here. Therefore, we have to consider that they all have came at 0 millisecond. Okay, so 0 is the arrival time for the process P1, P2 and P3, all of them. Okay, now a process P1 came first, so it is first come first serve, means that when a process will come to the ready queue first, that will be given for execution first. So P1 is given first here. From 0 to 24, we can see that this entire burst time, this P1 is executing, and P2 and P3 is waiting in that time. Okay. Then according to the order, after P1, P2 will come and P2 will execute for 3 milliseconds of time. So from 24 to 27, it will execute. And then P3 will come, it will execute from 27 to 30. Okay. Then after the execution, so this is the actual NAT chart. Okay, this NAT chart should be drawn for the scheduling algorithm problems. Then we have to determine the waiting time. So P1 came at 0 millisecond. I told you that arrival time for all the process P1, P2, P3, that is 0. So P1 came at 0 millisecond and it is allocated to the for the execution is at 0 millisecond. So 0 minus 0 will be the waiting time for the process P1, that is 0. And waiting time for the process P2 will be, P2 came at 0 millisecond and started execution from 24 millisecond. That means up to this entire time the process P2 has waited in the ready queue. Therefore 24 minus 0 will be the waiting time for the process P2. And P3, for the process P3, waiting time will be 27 minus 0 because P2 will execute for 3 milliseconds. After that P2 will left and then P3 will start its execution. and P3 came at 0 millisecond. So 27 minus 0 will be 27. So these three things were found, and we have to find the average waiting time. So average waiting time will be what? We have to add them. So for process P1 it is 0. Then 0 plus 24 plus 27 by 3, that will be 17. Then we have to find the turnaround time. See that turnaround time will be here P1 came at 0 and left at 24. So 24 minus 0, that will be the entire turnaround time. Okay. So for the process P1, 24 is the turnaround time. For the process P2 came at 0 and P2 is leaving the ready queue at 27. That means 27 minus 0 will be the waiting turnaround time. And P3 came at 0 and leaving the ready queue at 30. So 30 minus 0 equal to 30 will be the turnaround time. And if we want to find the average turnaround time, then that will be 24 plus 27 plus 30 by 3. This will be 81 by 3 means 27. So 27 is the average turnaround time. Okay. This is one algorithm. So here in this algorithm, we may face some problem that is called the convoy effect. Okay. In this convoy effect, actually we can see when the process P1 is given priority first, P1 will execute for 24 milliseconds, and in this time P2 and P3 has to wait. So when a process has the maximum CPU burst, then some other process has to wait for that time, and that is the problem that the processes are waiting here, and that is called the convoy effect, or you can say starvation also. Okay, this starvation happens in this time. Now we can see that when if we can allocate the process in some other order, means suppose we are allocating the processes at first of all P2, then P3 and then P1. Okay, what will happen there? So we have changed the arrival order. Okay, that is P2 came first, suppose, then P3 came, then P1 came. In this case, P2 will be given the CPU first, P2 will execute, and then P2 will leave. Then P3 will be given the CPU from 3 milliseconds, it will execute and then it will leave. Then P4 will be given the CPU and it will execute, then it will leave. Okay. Now we have to calculate the waiting time for every process. P1 will wait for how much time? See that we have told that the arrival time for the processes are 0 here. So 6 minus 0 will be 6. That will be the arrival time for the process. That will be the waiting time for the process P1. Okay. Then for the process P2, okay, P2 came at 0 millisecond and it is given to the CPU at 0 millisecond. 0 minus 0 will be 0. That will be the waiting time for the process P2. And P3 is given to the CPU at 3 millisecond and it has came at 0 millisecond. So 3 minus 0 will be 3. That will be the waiting time for the process P3. If we can find the average waiting time here, then that will be 6 plus 3 plus 0 by 3. That means 3 will come here, and this is actually better than the previous one. You can see in the previous case, what is the waiting time? 17 is the average waiting time. But if we go for the case of this case, if we change the order, then we can see that the waiting time is actually better than the previous one. Also you can see that the turnaround time is actually decreasing here. In the previous case, the turnaround time is average turnaround time is 27 here, whereas in this case the turnaround time is actually 13 here.